Economics and business, many applications require the use of lines and equations of lines. Hi, my name is Jason Rosenberry, and that's what we will be exploring today: slopes of lines, parallel and perpendicular lines, and their applications. Let's start with a definition of increments. If a particle moves from the point x sub 1, y sub 1 to the point x sub 2, y sub 2, the increments in its coordinates are delta x equals x sub 2 minus x sub 1, and delta y is equal to y sub 2 minus y sub 1. These symbols are read delta x and delta y. The letter delta is a Greek capital D for the operation difference. Let's try these out. Find the coordinate increments from point A, being at negative 3, 1, to point B, which is at negative 8, 1. Let's first find delta x. Delta x, which is defined as x sub 2 minus x sub 1, would equal x sub 2, the x sub 2 coordinate is negative 8, minus the x sub 1 coordinate, which is negative 3. So negative 8 minus negative 3 is negative 5. So delta x is negative 5. Now let's find delta y, which is defined by y sub 2 minus y sub 1. That would be 1 minus 1, which is 0. So delta y would equal 0. We use increments when we find the slope of a line. Let's look at how. Slope of a line. Let point P be located at x sub 1, y sub 1, and point Q be located at x sub 2, y sub 2, be the points on a non-vertical line L. The slope of line L is slope M equals rise over run equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Notice that the increment in the y direction is divided by the increment in the x direction, meaning y sub 2 minus y sub 1 was also known as delta y, and we're going to divide that by x sub 2 minus x sub 1, which was defined as being the increment of x. Remember also that parallel lines are lines that have the same slope, and perpendicular lines have slopes that are negative reciprocals of each other. Let's try a couple of examples. Let L be the line determined by the points A and B. A, plot A and B. B, find the slope of L. C, draw the graph of L. And we'll do this for two problems. Our first problem, we have the 2 points 1, negative 2, 2, 1. And the second problem, we have the points 2, 3 and negative 1, 3. So let's start with the points 1, negative 2 and 2, 1. First, let's plot the 2 points. 1, negative 2 is here. 2, 1 is here. Now we're going to find the slope of the line that passes through those 2 points. And again, slope is found by y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Making those substitutions, we would have 1 minus negative 2 over 2 minus 1. This simplifies to positive 3 over positive 1, so this line would have a slope of positive 3. Now we'll go ahead and draw the line through the 2 points. And there is our line. Second problem, we have the 2 points 2, 3, negative 1, 3. Plotting those 2 points, we're 2, 3, and the point negative 1, 3. Now we'll find the slope of the line through those 2 points. Again, slope is defined by y2 minus y1 over x2 minus x sub 1. Here we'll have 3 minus 3 over negative 1 minus 2, which gives us a 0 over -3, which is 0. So the slope of the line through these 2 points is 0, and as you'll see, this line will be a horizontal line. Let's move on to some equations of lines. Vertical lines. The vertical line through the point AB has equation x equals a, since every x coordinate on the line has value a. Horizontal lines. The horizontal line through the point AB has equation y equals b, since every y coordinate on the line has a value b. We can write the equation of a line that is not horizontal or vertical using the point slope form of the equation of a line. Point slope equation. The equation y equals m times the quantity x minus x sub 1 plus y sub 1 is the point slope form of the equation of a line through the point x sub 1, y sub 1 with slope m. General equation of a line. The equation ax plus by equals c, assuming a and b are not both 0, is the general form for the equation of a line. Write the general linear equation for the line through the points 0, 0 and 2, 3. Let's start by finding the slope. So slope would be 3 minus 0 over 2 minus 0, which is 3 halves. Now using the point slope formula, y equals slope 3 halves times x minus x sub 1, 2, plus y sub 1, 3. Multiply this out, we get y equals 3 halves x minus 3 plus 3. That simplifies to y equals 3 halves x, and now we'll put this in standard form, general form, multiply everything by 2. We get 2y equals 3x, which we can now write as 3x minus 2y equals 0. Another useful form of the equation of a line is the slope-intercept form. Let's take a look at it. Slope-intercept form. The equation y equals mx plus b is the slope-intercept form of the line with slope m and y-intercept b. Find the slope and y-intercept and graph the line 3x plus 4y equals 12. Let's go ahead and solve this equation for y. So we would have 4y is equal to negative 3x plus 12. Now we'll go ahead and divide everything by 4, giving us y equals negative 3/4 x plus 3. The slope is negative 3/4, and the y-intercept is at 3. To graph the line, we'll start by plotting the y-intercept, which is at positive 3. Then from that point, we'll use the slope, which says we go down 3 units and to the right 4. And now we'll draw a line through those 2 points. Now it is time for you to try a problem. Find the slope and y-intercept and graph the line x over 3 plus y over 4 equals 1. Pause the video while you work on this problem. When you are finished, restart the video and check your solution. Let's first solve our equation for y, but before we do that, let's get a common denominator and clear fractions. Multiply both sides of this equation by 12 yields 4x plus 3y equals 12. Now to solve for y, we'll subtract 4x from both sides, giving us 3y equals negative 4x plus 12. Dividing by 3 gives us negative 4/3 x plus 4. So the slope is negative 4/3 and the y-intercept is positive 4. We'll first plot the y-intercept at positive 4. From that point, go down 4 units to the right 3, and now we'll draw a line through those 2 points. Let's now see how lines might show up in applications. The pressure P experienced by a diver underwater is related to the diver's depth D by an equation of the form P equals KD plus 1. K is a constant. When D equals 0 meters, the pressure is 1 atmosphere. The pressure at 100 meters is 10.94 atmospheres. Find the pressure at 50 meters. So we have our equation P equals KD plus 1, and we know that when P is equal to 10.94, D is equal to 100. So we'll make those substitutions into the equation and solve for K. So P, 10.94, equals K times D, which would be 100K plus 1. Now we'll solve this equation for K, so subtracting 1 from both sides gives us 9.94 equals 100K. Dividing both sides by 100, we get K is equal to 0.0994. We'll now go back to the equation. We'll let K equal 0.0994. We'll let D equal 50. And we'll find out how many atmospheres that would be. So now we will find P. So now we will find P when K is 0.0994 times D. D is now 50 plus 1. And we do the arithmetic, and we get P is equal to 5.97. Therefore, the pressure at 50 meters is 5.97 atmospheres. In this lesson, we learned how to find the slope of a line, the equation of a line in many forms, as well as the characteristics of parallel and perpendicular lines. Be sure to work the exercises that your teacher assigns. We'll see you next time.